Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of polynomial equation. As per the problem, determine the value of k such that -2 is one root of the equation 2x cubed plus k plus 1 times x squared equals 4 minus x squared. Determine the other roots of the equation. Let's start with the first part. We have to find the value of k in this equation. The first step is to set this equation equal to 0. We do that by moving the negative x squared and the 4 term to the left side of this equation. So I get negative x squared changes to positive x squared and 4 changes to negative 4. In this equation, k plus 1 x square and x square are like terms. We can combine them. The coefficient of x square is an invisible one. So we should add the coefficients of these terms. K plus 1 is equal to k plus 2. This is a cubic polynomial. Let's assume this cubic polynomial can be represented by function f at x. As per the problem, -2 is one root of the equation. So as per the remainder theorem, f at -2 should be equal to 0. There is a very important concept we need to understand to solve this type of problem. Next, we should sub in x as -2 in the equation for f at x. F at -2 should be equal to 0, so we can sub in 0 on the left side of this equation. -2 cubed is equal to -8. -2 square is equal to 4. We have to solve this equation to find the value of k. We can distribute 4 into the parentheses. Next, we can combine the like terms. -16 plus 8 minus 4 is equal to -12. Next, we can move -12 to the left side of the equation. That will make this term positive. I get k equals 3. This should be the final answer for the first part. Next, we have to find the other roots of the equation. The first step is to sub in k as 3 in the given equation. We have to set this equation equal to 0, so we can move all the terms to the left side of the equation. This is the equation we get. As per the problem, negative 2 is one root of the equation. We can find the binomial factor for this equation. X plus 2 is a factor of the equation. We can find the other roots using polynomial division. We should divide the given equation by this factor. We can use long division or synthetic division. In this video, I'll use synthetic division. In the simplified given equation, there is no x term, so the coefficient of the x term is 0. For synthetic division, we should write the coefficients of all x terms and the number term. We can write the given root on the left side. Now we can start the synthetic division. We bring the 2 down. Negative 2 times 2 is negative 4. 5 plus negative 4 is 1. Negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. Negative 4 plus 4 is equal to 0. This last number represents the remainder of this polynomial division. It is equal to 0. So this proves that x plus 2 is a factor of the cubic equation we got. The degree of the given polynomial equation is 3. The degree of the factor is 1. So the degree of the quotient will be 3 minus 1, which is equal to 2. So we should assign x squared to the first number 2, x to the second number 1, and negative 2 is the number term in the quotient. Now we can write the equation in factored form. We can find the other roots of the equation by solving the complex trinomial in the second parenthesis, which is also the quotient of the polynomial division. It is not possible to factor this equation, so we'll have to use quadratic formula to solve it. We should set it equal to 0. This is the quadratic formula. In the quadratic equation, a is equal to 2, b is equal to 1, c is equal to negative 2. We can sub in these values in the quadratic formula. We get two solutions, one with a positive sign, one with a negative sign. So these are the exact values of the other roots of the given equation. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.